Hi there, welcome to my channel Mando to Fundo. In this video, I'm going to discuss about the solution for finding the majority element in a given array. Let's look at the problem description. We are given an array nums of size n and we have to return the majority element present in that array. So the majority element is the one which appears more than n by 2 times. So that means maximum only one element can be a majority element. Let's take a look at this example. We are the input is nums with 3 comma 2 comma 3. So 3 is majority, so the output is 3. In the second example, we have 2 2 1 1 1 2 2, 4 2s and 3 1s. So 2 is more than 3, so output is 2. So n is a number of length. So n is ranging from 1 to number of elements in the array ranging from 1 to 50,000, and the value can be ranging from minus 10 to the power 9 to 10 to the power 9. So we are expected to solve this problem with the order of one space and linear time. Let's look at the approach to solve this problem. So we have an input array of size 7. In that there are 4 numbers of value 2 and there are 3 numbers of value 1. So the majority in this is number 2. So we have to return number 2. So there are two approaches. One is a brute force method. So we can create a frequency map which has the number as the key. For example, here we have 1 and 2. So the key map have one entry for each of the unique numbers in that input array. And then as we traverse the input array, we increment the frequency of the particular number, and at the end we have a map with each unique number and its frequency. Then we can find the maximum frequency number by traversing the frequency map and then return the majority number. So the space complexity here is order of n, but we are expected to do order of 1 space complexity. The other approach is the transform and conquer approach. So in this approach, first we sort the input array so that all the duplicate numbers are grouped together. Then we can traverse that input array once. As we traverse, we can try to find the first number whose occurrence exceeds the count divided by 2. So the space complexity in this case is order of 1. Let's look at the flowchart. Input for this procedure is nums array. First we sort the input array so that all the duplicate elements are adjacent. Next we initialize the index and then the count and the frequency variable and then the majority variable. So the index will be initialized to 1 and the frequency will be set to 1. The count will be set to number of elements in the array and the majority is set to the first number in the input array. Okay. Then we enter the loop. We check whether we processed all the elements in the array. If so, then we come out and return the majority value, whatever is computed. Otherwise, we check whether the current number is equal to the previous number. If so, that means they are duplicate. So we increment the frequency variable. And then we check whether the frequency is greater than count divided by 2. Because as per the problem statement, whatever the number whose frequency is greater than count by 2, that is majority. And there can be only one number is possible to meet that condition. So the moment we see the frequency for greater than count divided by 2, we assign the num of the current number to the majority variable and then we come out of the loop. Otherwise, we keep proceeding to the next iteration. Then if the current number is not equal to the previous number, that means we are seeing a unique number. In that case, we have to simply reset the frequency to 1 to count the new number's frequency from now on. Okay. So whenever we see a new number, we reset the frequency to 1. Whenever we see a duplicate number, we increment the frequency. After increment the frequency, we check whether the is greater than half of the size of the array. Finally, we return the majority number. Let's move on to coding. First, I initialize the count variable to the number of elements in the array and the frequency to 1. Then I do sort the input array. The sorting will make all the duplicate numbers adjacent to each other. Next, this for loop will traverse the sorted input array starting from index 1. And in each iteration, it compares the current value with the previous value. If they are same, then it will increase the frequency. And then if we check if the frequency is greater than half the size of the array, that means we found the majority element. Current number is assigned to the majority variable and then break out of the loop. We initialize the majority variable with the first number of the element array. So if the numbers are not matching, then the frequency will be reset to 1. Next, I'm going to run the test cases. Okay, all the tests passed. Next, I am going to submit this program. Cool, this program is accepted. Next, I am going to do the code walkthrough with sample input. Let's do the code walkthrough for this input. Input array is totally 7 elements, and out of which there are 3 1s and 4 2s. So the majority in this array is number 2. First, we initialize the count to 7. The frequency is initialized to 1. First element in the array is set as a majority. Okay. Then next we do sort the input array so that all the duplicate numbers are adjacent to each other. Okay. We will traverse this sorted array and then we count the number of occurrence of each number. Whenever we see the duplicate number, we increase the frequency. Otherwise, whenever we see a new number, we reset the frequency to 1. After that, we check the frequency is greater than half the size of the array. In that case, that current number pointed by idx is the majority, and then we break out of the loop and return the majority value. Okay. So in the first iteration, in iteration 0, when we enter, the frequency value is 1. And num array is the idx is pointing to the index 1. Okay. So when we compare these two numbers, both are same. So the frequency is incremented. So at the end of the iteration, we see the frequency as 2. So in the next iteration, when we enter, the frequency is 2 and the IDX is pointing to the index 2. It is equal to the previous number. So the frequency is incremented to 3. And the iteration 2, the index is pointing, IDX is pointing the index 3. So which is 2. And that number is not equal to the previous value 1. We reset the frequency. From here onwards, we count the frequency of number 2. So when we leave that iteration, so we have the frequency reset to 1. And in the next iteration, the IDX is pointing to index 4. So which is equal to the previous value. So we increment the frequency. And in iteration 4, the IDX is pointing to the 5th index in the array. So we increment the frequency. Now it is set to 3. In the last iteration, IDX is pointing to the last number, which is equal to the previous number. So we increment the frequency to 4. And then the frequency is 4 and the count is 7. The total number of elements in the array is 7 divided by 2, which is 3. So 4 is greater than 3. So we assign the majority. The current number 2 is the majority number in the array. So we return that value. Next, I'm going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for this input. For this input, we have 7 elements in it. And the first thing we do is we do the sorting, so that the complexity of this sorting is order of n log n. And then we scan n minus 1 number of elements. So for this case, we traverse 6 elements starting from the index 1 all the way to the last element. 6 times this loop runs. So the total time complexity is n log n plus n. So we take the dominating factor, which is n log n here. So time complexity is n log n. Next, the space complexity is order of 1, because we are not allocating any additional space in this function. You just use only few variables. So the space complexity is order of 1. Thanks for watching this video. Have a great day.